Welcome back. So we'll continue with our discussion on multicast. I'm sorry if I've bored you with a lot of PIM stuff, but I promise this is the last video on the PIM series, right? Basically on the PIM protocol, because we have covered the dense mode, we have covered the sparse mode. The one remaining is the hybrid of that. That's the sparse and dense, PIM Sparse-Dense mode. Now, just to recap, in our sparse mode, what we do, we have the pull model, right? So this guy is the pull model, where the multicast traffic is kind of pulled, or the clients basically go and request for the multicast traffic. If you don't request, sparse mode will not forward the multicast traffic to you. Whereas this one is a push model. Whereas where the routers are going to basically flood the multicast traffic on all the interfaces until they receive a prune, right, from the downstream routers, right? So the third one where we are going to discuss is a combination. So why we need this, right? To understand why we need this particular mode, you need to understand something interesting here. So when you use your PIM sparse mode, right, we talked about RP, didn't we? We introduced the concept of RP. Now RP we talked about, we said there are two ways of RPs, or two ways of configuring RPs, static and dynamic. When you are doing static, you don't have any issues, and we took care of that in the previous video. This was good. Now dynamic, there are multiple dynamic ways, right, like your auto RP, right, BSR, right? We'll look into detail probably each of these in other videos, but for this video let's just concentrate on what? On my auto RP here. Let me just reduce the size of this a bit, right? So let's concentrate on this auto RP feature, right? So auto RP in simple terms, it's basically you're making the network itself figure out who wants to be RP, right, based on some rules, say some loopback address IPs and all of that, right? So based on that, it is trying to figure out who wants to be RP, right? And then it is also taking the responsibility of kind of announcing that RP to the rest of the network. That's the whole idea behind auto RP, right? Now this group to RP mapping, right? Group to RP mapping in the sense, any multicast group, like say 239.1.1.1. So this is a group, right? And for this particular group, let's say we have an RP now, right? One auto RP was created. Let's say R1 is the RP, or the loopback on R1 is the RP. Now that information, right, like I said, that has to be announced to the rest of the network, right? But to make things worse, what we have is, we have the sparse mode, right? Now imagine the situation is also, the other thing is here, this information, right, about the group to RP mapping, this information is set to address which is 224.0.1.40. We saw this address repeatedly appear earlier, right? So this is the address to which this information is sent, which is fine. But the problem is, very interesting problem, is we have sparse mode running, right? And what is the thumb rule of sparse mode? The thumb rule of sparse mode is that to receive any traffic, you have to request it from RP, right? But what is happening now, the information or the update, right? This is the update. This is the most critical update for you right now. Without this, nothing will work. What is this update? The update is about who the RP is, right? That update has to be somehow communicated to everyone in the network. But to communicate this update, there should be an RP already present. So you understand the situation, right? It's more like a chicken and the egg problem, right? So this update is itself about telling everyone who the RP is, but to consume this update, you need some kind of an RP in the network, right? So it's going to be like a paradox, right? It's not going to work out, right? So that's where we come across this interesting mode, or that's where we use this mode, which is the sparse and dense mode, right? So in simple terms, what it helps is, it helps you to kind of flood initially it will help you to flood this information, right, the RP in a group to RP mapping, right, to everyone in the network. Once everyone have received the information, then the network will kind of like fall back to sparse mode, because sparse mode is the most optimal one. Also, if in future if there is some other multicast group for which RP is not present, right, auto RP is not present, right, then in that case the network will fall back to using the dense mode, right. So it's kind of like, you can think of it as the most reliable one, right, because if you have sparse mode, if you have everything needed for the sparse mode, it will work in the sparse mode. If not, it will fall back to dense mode, right. So that's the whole idea behind it. But I hope you understood this interesting problem, right. So just the Y part is very interesting, right. So just to recap here, when you're using PIM sparse mode, you need to have an RP in your network. RPs can be designated either in a static way or dynamic way. Auto RP is a way of kind of dynamically assigning or announcing the RPs in the network. But the problem is you can't, or no one in the network will be able to consume this update as to who the RP is, because they don't know who the RP is as of now, right. So without knowing the RP, they can't consume any updates. But this update is also about who the RP is. So it's like more like a chicken and the egg problem. So to solve that, we have this very interesting mode, right, which we are going to look into now. Alright, now let's do the configurations and see how this actually solves our problem, right. First step, let's go and enable. So I have just a startup config. I have basically enabled OSPF in the whole domain, right. That's it, not done anything other than that. So let's go and enable multicast routing on all the three routers, R1, R2 and R3. And R3, let's go to R3. Okay, and what we'll do next is we'll enable the sparse dense mode on the interfaces. So on R1 we'll have to enable it on 2 interfaces, and probably on the loopback as well. I don't think I've created a loopback. Have I created a loopback here? Let's check. To show IP interface brief. Okay, I don't have a loopback. So let's create a loopback. Let's say loopback 0. IP address is 1.1.1.1. 55 to 55. Is that correct? Yep, looks good. Alright, and let's also get this guy into my OSPF. So it's going to be 1.1.1, 0.0.0, let's say area 0. Awesome. So now what was I telling? I have my loopback up, which means let's go and enable your we'll have to do that. So we'll have to enable the PIM sparse dense mode, right, which we are talking about. We'll have to enable it on which and all interfaces, 0, 1, 0, 2 and 0, 0. And 0, 0. So let me just copy this from here. Alright, so there you go. So let's go and do that. Okay, did I make a mistake? 0, 0, 0, 1 and 0, 2. Okay, let's do that once again. I missed something. Awesome. So that's done on R1. Let's do on R2. We will basically need, do I need any captures here? Probably. It's not, I think captures are not needed because I've already showed you most of the captures. All the captures, all the messages are going to remain the same. We'll just use debugs for this lab. Alright, so where are we? R2, where is 0, 1, 0, 2 and that's it. I think that's what you want. So let's go and do that. And the last guy, which is my R3, where you want 0, 0 and 0, 2. That's my R3. Awesome, done. So we've enabled the sparse dense mode, which is the core of our discussion today. And what we'll do next, we'll enable auto RP, right? So when we have to enable auto RP, we'll have to configure what we call as a mapping agent, right? So we'll have to configure, in our case, we'll just configure R1 loopback itself to be the mapping agent, and it will then announce to the rest of the world or rest of the network that it is the RP, right? So to do that, we'll have to do IP PIM send. Is that correct? Okay, let me send dash. Let's go back. I think it's a global conflict. All right, so IP PIM send RP announce loopback 0. Loopback 0, we'll have to put a scope, right? The TTL, okay, we'll put 5. If you have a big network, probably you can increase that. And the other one is IP PIM send RP discovery, and we're gonna say loopback 0 and the same scope 5. So now we have done with the whole non-IP or PIM interface ignored in except command. Is that let me just check. IP PIM send RP discovery loopback 0 scope 5. Yeah, I think it's fine. Let me just check if the commands went in. RP discovery has gone in, and the announce, I don't see the announce command. Let me try to put that again. Let me make a mistake. Oh, okay. I think I've not configured the PIM on the loopback. That's why it's shouting. It doesn't like that. So let's go to the loopback 0 and let's enable the dense mode. Okay, so we've enabled the dense mode. Now we will do the two commands basically for auto RP, right? One is RP announce and the other one is the RP discovery. There we go. So that's done. Now let's go and see the PIM neighbors. Nothing special here, pretty straightforward. On R1 we have R2 as my PIM neighbor, right? Let's say on R2 we should have 2 of them as the PIM neighbors. To show IP PIM neighbors. There you go, we have 2 of those guys, and similarly on R3 we should have probably 1 of them, right? Want to check? Probably we can check that. So everything is good with respect to PIM, right? The PIM neighborship is up. Now this is where you will see the magic, right? We have enabled sparse dense mode, right? And we have made R1 loopback as my RP right now, and we have configured auto RP and all of that. Ideally, right, if you are running only sparse mode, your R3 especially should not have gotten the update, right? It shouldn't have gotten the update ideally, but that won't be the case. We'll see that. So we'll go to R2, let's clear the screen. Let's run show IP PIM RP mapping, right? This command takes a bit of time. I've never figured out why. It takes a bit of time to load for some reason. Meanwhile, let's run the same thing on my R3 as well. There you go. You can see the PIM RP mapping has arrived on R2, and what it is telling that for the whole multicast range, 1.1 is acting as the RP. Right? Do you think R3 has learned? Yes, R3 also has learned the RP mapping, the same RP mapping. Right? Now, if you see the routing table on my R1, let's check the routing table for that route 224.0.1.40, right? That's my group. That is the group to which the update is sent. Let's see what has happened here. You can see for this group, the flag which is attached to this group is the D flag, which is the dense mode, right? So it clearly understands that what is happening is R1, right? As soon as you configure it as an auto RP, right? It will use this multicast group to, announce to the world that he is the RP, but he is going to do it in a dense mode, right? Because you use sparse and dense mode, it will fall back to dense mode to announce this good news to the world, right? That's why, because it is falling back to dense mode, that is why our guys, our R2 is receiving it, right? Our R2 will receive it. Let's see on R2 what is the mode, right? You can see here R2 is receiving it, okay, and you can see it has received here. It knows that for this group right, 1.1.1, right, it has received the source as 1.1.1, which is the RP, right. Now you can also look at the flags, LNT flag, right, over here. Let's look at R3 as well, same thing, right. You can see here the flag is D flag, which means it is receiving the information in the dense mode, right. And this was only possible because you are running sparse dense mode. If you are running only sparse mode, then this update would have never reached this guy, because for him to reach the update he needs to know RP, right. But without the update he'll never know RP. So it's more like a paradox. Because you use the sparse dense mode, now that information was able to travel throughout the multicast network. Alright, cool. Next, let's probably also run another quick command to see the mapping, the group. Did we do that already? I think we did it here, right? We did it here. So we understand that since we did not put any access list, or we did not restrict it, the R1 is serving as the RP for the whole multicast space, which is 224.0.0/4, right? That's your default multicast space, right? So it is serving as the RP for everything. What we'll do is we'll go to one of our hosts, which is H1. We'll go inside the interface Ethernet. Let's go inside the interface Ethernet 0/0, and we will join the multicast group. Say one of the multicast group, anything. It can be anything now, because the RP is serving as the RP for the whole multicast space. So let's join 239.1.1. Once you join that space, let's go to my server right over here, and let's generate some traffic to that particular group, right. There you go. Do you think will this succeed? Let's see. Yeah, it has received the response, right. So it succeeded. So S1 generated the traffic, our H1 was listening to it, and it responded, right. So H1, which is behind R3, has responded. Now let's see what has happened on my R3 here, right. So let's clear the screen a bit, right. So on R3 I want to see the multicast route for this for this group which I just now kind of joined in, right. So let's see what has happened. So if I do something like show IPM route, my bad, and put in this particular guy, you should see. There you go. We see, right, which mode was used to forward the traffic now? The sparse mode was used, right, because now R3 already knows the RP, right. It is falling back to, or it is using the most optimal mode, which is your S, which is the sparse mode, right. Look how interesting it is, right, how intelligent it is. Initially, because there was no RP, the dense mode was used to populate, or to kind of to broadcast the RP to the entire multicast domain. Once everyone knows who the RP is, we are falling back to the sparse mode, right, to forward the traffic, which means now the data will all be sent to the rundown point, and obviously then the whole concept of RPT comes in, and RPT will get switched to SPT, and that's why you see the T bit here. So now it has joined the SPT, which is the source tree. From RPT it has switched to source tree, right, and this is the source 192.168.1.101. So it has, in this case there is only one path, so RPT and SPT will remain the same, but otherwise if you had multiple paths here, then it would have been different. Cool. So that's one use case. What I wanted to show here is, initially it uses dense mode to broadcast your RP. Once the RP is known to everyone, when you join a particular group and when you send the traffic, multicast traffic to that group, we saw that on RP we were using sparse mode to forward the traffic. We were using the sparse mode because it is the optimal one. Now let's do something interesting. Let's use an access list, right, on my R1. Let's create an access list, and I'm basically going to say this access list is going to have just 239.1.1, and I'm going to use this access list with the auto RP, which means what I want to do is basically I want my RP or my R1 to be the RP only for one particular multicast address and not for the whole subnet like we did earlier. So we're going to say IP PIM send RP announce loopback 0, scope is 5, group list, right? And we'll have to use this one which we created here. So now what we did is, this guy is going to be the RP only for whom? It is going to be the RP only for this guy, 239.1.1. Let's see if that mapping has come down on my R3. It might take some time. If it takes some time, the best way to do is probably we can use the clear command to clear the mappings, right? There you go. Let's clear it on all the three guys, on R1, on R2, and on R3. There you go. After clearing the PIM RP mapping database, now you can see, you can compare the output, right? Here earlier R1 was serving as the RP for the whole subnet 224.0.0/4, but now you can see because of the access list, R1 is serving as a RP only for this subnet, or not subnet, for example, the only multicast group, only for this multicast group it is serving as the RP. So what we'll do now is, let's get this guy on H1, let's join a different group, that is, let's say 3.3.3, for which obviously R1 is not the RP, right? So we have joined this guy, and on my server let's generate some traffic for this new group. Now when I generate traffic, what do you think, will the ping work or not, right? Our current situation is that our RP which is on R1 is only serving 239.1.1.1 because of this access list. So it is the RP only for this guy, and you can see that on R3 it is reflecting, right? It is only 1.1.1 and it is serving only this particular multicast group. So now we have a host who has joined in for a different multicast group, and we are generating traffic. Let's see if this works. There you go. I'm starting to get some reply. Let's wait. Awesome. Look, it worked. Isn't that surprising? Because our RP should not have worked. So how did this ping actually work? So let's go back and check. Right. So if I run the same, if I go back to my routing table, show IP mroute. But this time let's do 239.3.3.3, and there you go. What has happened? Look here. We have used the D flag, which means it did not use the sparse mode, rather it did a fallback and it went down to the dense mode. Why did this happen? Because it was not able to find any RP for this particular multicast group, right? So PIM was intelligent enough to fall back to the D mode, which is the dense mode, right? So that's really a cool thing about the sparse and dense mode, right? So whenever sparse mode is possible, whenever you have the RP for that group, it's going to use the sparse mode. But when there is not, it will fall back to the dense mode. As a result, you'll never have any kind of your traffic will always flow. I mean, dense mode is obviously not very scalable and not very it's not optimal, obviously, because you're basically ending up flooding packets everywhere. But still, it's better than not having the ping at all, right? Not having the ping working or not having connectivity. So it's a fallback method here, right? So okay, so that's mainly what I wanted to touch base in this one. So I think we have covered all the three modes now. PIM, dense, we did sparse, and we did the sparse-dense. The sparse-dense was little interesting because we kind of looked at solving a couple of interesting problems as to, when you have a sparse mode, you have auto RP configured, how do you make your auto RP update propagate in your network, right? So we solved that problem by using the sparse-dense mode. And then we also saw that once the once the routers along the path realize who the RP is, they will all fall back to the sparse mode. But if in future if there is some traffic directed towards a multicast group which doesn't have an RP, then it will fall back to the dense mode, right? So you have everything covered down here. Alright, thanks for watching guys. Have a good one. Bye.